Welcome to the DIY Honda Garage channel. The presentation addresses Diagnostic Trouble Code DTC P2185, which indicates a high voltage condition in the Engine Coolant Temperature ECT Sensor 2 circuit of the Honda CRV models from 2011 to 2016. Understanding this DTC is crucial for effective troubleshooting and repair, as it points to potential issues with the ECT sensor or its associated wiring and connections. The ECT sensor plays a vital role in monitoring the engine's temperature, and when the voltage exceeds the threshold of 4.92 volts, it leads to the P2185 code being triggered. Our goal today is to follow a systematic approach to identify the root cause of the error and rectify it, ensuring that the vehicle operates within its designed parameters. This presentation will guide you through detailed troubleshooting steps specified for this code, aiming at restoring the vehicle's optimal function and eliminating any driving concerns associated with this error. DTC P2185 refers to a high voltage condition in the ECT Sensor 2 circuit, signifying that the voltage being read exceeds the expected threshold. The ECT sensor, located in the engine compartment, is crucial for measuring the engine's coolant temperature and transmitting this data to the Powertrain Control Module, PCM. This information is vital for adjusting fuel delivery and ignition timing, thus ensuring optimal engine performance. The ECT Sensor 2 operates alongside other components to maintain efficiency and monitor engine conditions. If the voltage exceeds 4.92 volts, as stated in diagnostic specifications, it indicates a malfunction in the sensor or the circuit, necessitating further investigation to determine if the issue is with the sensor itself, wiring, or connections. Understanding the exact location and function of the ECT sensor is critical in the troubleshooting process. Several possible causes can lead to a high voltage condition in the ECT Sensor 2 circuit. First and foremost, a faulty ECT Sensor 2 itself may produce incorrect voltage readings. Secondly, loose connections at the ECT sensor or the PCM can cause fluctuations in voltage, leading to erroneous diagnostic codes. Additionally, damaged or frayed wiring in the sensor circuit can result in high resistance or shorts, affecting the voltage level. Each of these components is interconnected, and a failure in any one can trigger the P2185 code. It is essential to thoroughly inspect the wiring harness and connectors as part of the troubleshooting plan to eliminate any structural issues. Taking time to identify these possible causes will save time and resources and ensure a smooth repair process. When DTC P2185 is triggered, various symptoms may manifest that indicate a potential problem within the ECT Sensor 2 circuit. One of the most common symptoms is the illumination of the check engine light on the dashboard, alerting the driver to a fault in the engine management system. Increased fuel consumption may also occur, as the PCM may struggle to optimize fuel delivery due to inaccurate temperature readings. Furthermore, the vehicle's overall engine performance might decline, leading to rough idling or poor acceleration. Being aware of these symptoms is crucial, as they can help diagnose the underlying issue quickly, preventing further mechanical complications. If left unaddressed, these symptoms can lead to more severe engine problems, so prompt attention to DTC P2185 is essential for maintaining vehicle health. The first step in troubleshooting DTC P2185 involves verifying the problem through initial checks. Begin by turning the ignition switch to the on/to position, ensuring that the vehicle's onboard diagnostic system is active. Next, utilize the Honda Diagnostic System, HDS, to check the parameters related to the ECT sensor 2. Specifically, assess the voltage readings and confirm that they exceed the specified threshold of 4.92 volts. If the reading is consistent with this value, it indicates that the failure can be duplicated. However, if the voltage is below this threshold, then intermittent failures may exist, and it is wise to inspect for any poor connections or loose terminals associated with the ECT sensor 2 and the PCM. Accurately performing this step is crucial, as it establishes the groundwork for more focused diagnostics on the sensor and wiring. In the second step of troubleshooting, it's important to isolate the ECT sensor 2 to determine if it is functioning properly. Start by turning the ignition switch to the lock position, ensuring the system is entirely off for safety. Proceed to disconnect the ECT sensor 2 2-pin connector to access the terminals. Once disconnected, utilize a jumper wire to connect terminals A and B, specifically Terminal A, gray, and Terminal B, pink, of the ECT sensor 2 2P connector. Turn the ignition back to the on 2 position, and again check the HDS for the ECT sensor 2 value. If the voltage measures more than 4.92 volts, this suggests that the sensor is indeed faulty and replacement is necessary. However, if the voltage does not match, further investigation into the wiring and connections is required. This step helps in confirming whether the issue lies specifically within the sensor itself. For the third troubleshooting step, attention shifts to examining the wiring associated with the TW2 sensor line and SG6 line. Again, start by turning the ignition switch to the lock 0 position. After this, remove the jumper wire used in the previous step and turn the ignition back to the on position. It is crucial to measure the voltage between specified test points, namely test point 1 at ECT sensor 2P connector number 2, pink, and test point 2 at body ground. This provides an accurate reading of the wiring condition. The expected voltage reading should be approximately 5.0 volts. Should the voltage be correct, it confirms that the TW2 sensor wire is functioning as intended, and one should proceed to the next step. However, if no such voltage is detected, further diagnostic testing will be required to isolate issues within the TW2 sensor circuit. Proper voltage assessment is vital to ensure that the wiring is intact and functioning securely. The fourth step involves focusing on checking the integrity of the SG6 line, which connects the PCM to the ECT sensor. Begin again by turning the ignition switch to the lock 0 position to ensure safety. Next, it is important to jump the SCS service check signal line with the HDS to initiate communication for testing. After that, disconnect the PCM connector A, which consists of a 49-pin configuration. At this point, check for continuity between two defined test points: the SG6 line at PCM connector A, pin number 10, gray, and ECT sensor 2, connector number 1, gray. If continuity exists, it affirms that the SG6 wire is intact. In cases where continuity is evident, consider updating the PCM software if it is not up to date, or substituting it with a known good PCM to verify functionality. If continuity is absent, this indicates an open circuit that necessitates repair in the SG6 wire between the PCM and the ECT sensor 2, addressing any underlying faults in the wiring. In the fifth troubleshooting step, the focus shifts to examining the integrity of the TW2 sensor line within the broader wiring system. Start by turning the ignition switch to lock 0, ensuring that the system is safe for further testing. Utilize the HDS to jump the SCS line as before, activating it for effective continuity testing. Disconnect the PCM connector A, 49P. Once again, preparing for continuity checks. Measure between the TW2 sensor pin at PCM connector A, pin number 44, pink, and ECT sensor 2, connector number 2, pink. A successful continuity check indicates that the TW2 wire functions as intended. If it is confirmed to be intact, consider updating the PCM software if needed, or substituting it with another known good unit. However, if continuity is not established, one must locate and repair any open circuits in the TW2 sensor wire connecting the PCM to the ECT sensor 2. Verifying continuity in this line is essential for restoring normal operational parameters. Final repair verification is critical to ensure that the problem has been adequately resolved. Start by turning the ignition switch to the lock 0 position before reconnecting all connectors that were previously disconnected during troubleshooting. Once all connections are secure, turn the ignition switch to the on 2 position once again to allow the vehicle system to activate. Next, it is vital to reset the PCM using the HDS to clear any existing DTCs and refresh the system. Following this, conduct an idle learn procedure to enable the PCM to adapt to any changes made during repair or replacement actions. Finally, check for any pending or confirmed DTCs using the HDS. If DTC P2185 is still indicated, further investigation of the wiring and connections must be conducted. If no DTCs are present, the troubleshooting process is complete, and the repair can be considered successful. Preventive maintenance is vital to ensure the longevity and reliable operation of the ECT sensor, as well as the overall engine performance. One of the best practices includes regularly checking the connectors associated with the ECT sensor and ensuring that they are clean, free from moisture, and securely fastened. Furthermore, it is important to periodically inspect the wiring harness for any signs of wear, fraying, or corrosion that could lead to high resistance or shorts in the circuit. Additionally, routine checks on the function of the ECT sensor itself can preemptively discover issues before they escalate into significant failures, potentially triggering DTCs like P2185. Implementing these maintenance steps can enhance the vehicle's reliability, reduce repair costs, and ultimately lead to a more enjoyable driving experience. Thus, taking the time to prevent potential issues is just as integral to vehicle care as reactive repairs. In conclusion, DTC P2185 signals a high voltage condition within the ECT sensor 2 circuit, demanding thorough diagnostic and troubleshooting measures. Understanding the role and function of the ECT sensor and addressing possible causes, such as faulty connections or damaged wiring, is essential for effective repairs. The outlined troubleshooting steps provide a comprehensive framework for identifying and resolving the root cause of this DTC and thus restore optimal vehicle performance. Final verification steps confirm the success of repairs, ensuring that the same issue does not recur. Moreover, preventive maintenance practices can further fortify the sensor's reliability and prevent future codes from emerging. The knowledge gained from this analysis is instrumental in fostering both quick diagnosis and efficient repairs, solidifying a deeper understanding of Honda vehicle systems. Please like and subscribe to the channel. See you next time.